In this short video, we're going to talk about multiple regression and how we can use data to determine a relationship between multiple independent variables and one dependent variable. In a previous example, we used the fictitious company called the Butler Trucking Company to figure out if there was a relationship between the time of delivery and the distance that the truck drivers had to travel in order to make those deliveries. However, in this previous analysis, the analysis explained 60% of the variability found in the data. However, managers want to also figure out if there was another factor that had some influence on the time. The managers decided to look at the number of deliveries per assignment to see if that had a relationship with the actual delivery time. So in order to do that, we have to use multiple regression, where we would develop a model or an equation showing the relationship between more than one independent variable and one dependent variable. Here is the data that we want to use in order to complete our multiple regression analysis. We have the assignments, we have the miles traveled for each assignment, we have the deliveries for each assignment, and we also have the time elapsed for each assignment. What we want to do is build our regression so that we can look at the relationship that miles and deliveries have on time. To do that, we click Data Analysis from our Data menu in Excel, and we get our dialog box, and the dialog box has regression in it, so we're going to use that tool. And in the different ranges, looks like I had some ranges in here from another analysis, so I'm going to clear those out. We're going to select the data for the Y range. That's going to be time. And with this particular spreadsheet, we're going to select all of the data points to make sure we have as much as we can to complete the analysis. I think we have 300 or so data points, so we're going to use all of those. In the input range, we're going to select both the miles and deliveries columns so that we have both sets of data as it relates to the dependent variable of time. So let me make sure I got this right. That should also be a 1. All right. So we're going to straighten this out. That looks good. And then the output range is going to be at the top of the spreadsheet here. Okay. So when we click OK, here's what we end up with. We end up with the multiple regression analysis, and I'll make this a little bit bigger so you can see. The key thing that I want to see here is what does our square look like, and it is 0.81, which means that 0.81% of the variability in all of the data is represented by our model, and that's not bad, actually. The closer we get to 1, the better. The next thing I want to look at is the coefficients for the intercept, the miles, and the delivery. So as you see here, the intercept is 0.12. The miles, that coefficient is 0.067. And the deliveries coefficient is 0.689. So what does all of that mean? Well, then our equation simply becomes, and I'll type it here, y, which is going to be time, is going to be equal to 0.127, which will represent the intercept, plus 0.067 times miles, whatever the miles are, plus 0.689 deliveries. That is your equation for your multiple regression analysis. And what it's basically saying is that miles contributes 0.067 to the time, and the number of deliveries contributes 0.689 to the time. So it looks like, based on our analysis, that deliveries has more of an impact on the amount of time for each driving assignment.